This video is about compound interest. If you watched the last video, then we talked about simple interest in that one. So compound interest is still calculating interest, but it's a different type of interest. So we're going to look at both in this video and compare the two. So hopefully that'll help you be able to understand the difference between the two. All right, so let's look at some of the wording we're going to need to know. A lot of it is the same as what you saw in simple interest. So before we talked about an amount that was deposited or borrowed. We called that the principal. That's still called the principal. Spelled a little differently than the principal at school, but it's pronounced the same way, principal. So it's the amount that you deposit in the bank, like in your savings account, or the amount you borrow, like for a loan for a car or something. All right, so the amount you pay, that you're paid, or the amount you earn, for the use of the money. So if you borrow that money, this is the amount you have to pay for borrowing, or the amount the bank pays you for the use of your money. If that's paid only on the principal, then that's called simple interest, and that's what we found before. So when you pay interest, or when interest is earned on the original principal, plus the interest earned in the past, all right, then that's a little different than what you found before. So simple interest was always paid on the principal, and that principal didn't change. With compound interest, the principal is going to change. So every time you earn interest, they're going to add it to the principal, and so that principal goes up at the end of however long. So if they're going to pay you interest at the end of the year, then at the end of the year, your principal will increase by whatever your interest was. Whereas in simple interest, they'll give you the interest, but they don't change the amount of principal. All right, so the way it works is at the end of each time period, the interest earned is going to be added to the principal, and then this becomes the new principal for the next time period. All right, so this may seem a little confusing at first, but we're going to look at an example which I think will help you understand what's going on. So there is a formula for finding compound interest, but before we talk about that, I want to just show you how you can find both using the simple interest formula. So it's the same as what we were using before. Interest is equal to the principal times the rate times the time. All right, so in this example, Jonathan deposits $2,000 in a college savings account. He earns an interest rate of 5%. How much will be in the account after 4 years? Compare simple interest to compound interest. So in this first table, we're just going to look at simple interest. All right, so his principal is $2,000. He leaves it in for a year at an interest rate of 5%. So we need to change that percent for using the formula. Principal times rate times time. Then we want to do $2,000. The rate is 5%, so I'm going to change that to 0.05, and then we're just leaving it in for a year. He leaves it in for 4 years, but we're just going to look at what happens at the end of each year. So after the first year, how much interest did he earn? All right, so now I need to multiply 2,000 times 0.05. Sorry, this is really hard to write on. 5 times 0 is 0, 5 times 0 is 0, 5 times 0 is 0, 5 times 2 is 10. And then there are 2 decimal places, so I'm going to move it over 2 places. I don't need to do this 0 right here because that would just give me all zeros. So at the end of the year, he's earned $100 in interest, right? So that's what's said here. So his principal was $2,000. At the end of the year, they pay him $100. So his total now in his college savings plan is $2,100. Okay, and then we start year 2. Now, at year 2, he has $2,100, but they don't change the principal because this is simple interest. And so interest is paid only on the original principal. So that hasn't changed. So we're going to do $2,000. Because he's just paid interest each year, so the interest doesn't change, he's going to get another $100. So $2,000, the end of year 2, is going to be added, or I'm sorry, not $2,000, $100 is going to be added to what he had before. Same amount of interest that we found before. It's going to be added to the amount that he earned earlier. So I'm going to add $100 to this amount here, and I get $2,200. All right, so the end of year 2, this is how much is in his college savings account. Okay, and then I start year 3. Year 3, my principal doesn't change because this is simple interest. Right, so I'm going to do another year of interest. Still going to be $100. because 2,000 times 0.05 is still $100. So at the end of year 2 or year 3, I can add another $100 to what he had. And so now he has $2,300. All right, so I start my year 4. His principal is not changing. It's what he deposited at the very beginning. That's going to be the principal all along. His interest is not going to change because it's always the same amount on the same principal. So when I add $100 again at the end of the year, and now he's up to $2,400. All right, so you start it by depositing $2,000. After 4 years, he now has $2,400. Okay? All right, now compound interest, it's similar but a little different. He starts with the same principal, $2,000. He puts it in for a year. We know the interest rate is still going to be $100 because it's still the same rate. So 2,000 times 0.05, this part doesn't change. It was $100. So when we add that to the 2,000, we get $2,100. Now, here's where it's different. Okay, so compound interest says, all right, so we're going to change the amount of your principal now to this. All right, so instead of this being 2,000, like it was originally, the end of year 1, we get to change the principal to 2,100. All right, so this time when I pay interest, I'm paying it on this amount, not this amount. So it does change how I find the interest. So I'm going to do 2,100 times 0.05. It's really hard to read. Sorry, I'm going to rewrite that. 2,100 times 0.05. All right, so 5 times 0 is 0, 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10. Move my decimal over 2 places. So 105. I could multiply it times 1 year, but that wouldn't change it. All right, so at the end of year 2, because my principal was different, my interest is different. So it's a little bit more this year. It's $105. All right, so now if I add that amount to the amount that was my principal, 2,100, if I add that to this, and my new amount is going to be 2,205. Okay, and that gets to be my new principal, 2,205 over here. All right, so I leave it in for another year. This time the interest rate doesn't change. I'm going to leave it in for a year, but I'm multiplying by a different principal. So 2,205 times the same interest rate, 0.05, gives me 25, carry your 2, times 0 is 0 plus 2. 5 times 2 is 10. 5 times 2 is 10 plus 1 is 11. Move my decimal 2 places. All right, so the interest rate after the 3rd year, or the interest, is $110.25. All right, so a little more than the last year, and because the principal was different. So now I get to add that. Adding that, and I need to add 2 zeros in order to add that. So this becomes 5 plus 0 is 5, 1, 3, 2,000. Okay, so 2,315.25. All right, then I get to change that over here to this. Okay, so my new principal is $2,315.25. This is what I multiply times the same interest rate. So 2,315.25 times 0.05, and then times 1, so that doesn't change because it's just a year. So 25, carry your 2, 5 times 2 is 10, plus 2 is 12, 5 times 5 is 25, plus 1 is 26, carry your 2, 5 times 1 is 5, plus 2 is 7, 5 times 3 is 15, 5 times 2 is 10, plus 1 is 11. There's 1, 2, 3, 4 decimal places. So 1, 2, 3, 4. Put it between the 5 and the 7. All right, and because this is money, I can't use all of these decimal places here. So I'm going to round to the nearest cent. So since the 2 is not 5 or bigger, then this is just going to be $115.76. All right, and then I add that to what I had before, $115.76. So that gives me 11, 10, 11, 3, 4, $2,431.01. So then this is the amount after 4 years. All right, so if we look now at the differences between simple interest and compound interest, we can see simple interest, easy to find, same amount each time, so it's easy to figure out. But at the end of 4 years, he has $2,400. Okay, after 4 years with compound interest, okay, so it's a little more complicated, but at the end of 4 years, he's got a little bit more money, $2,431.01. Okay, which may not seem like such a big deal. Okay, it's a $31 difference. But if you keep compounding that, okay, if you did this for another 4 years or another 40 years, okay, then this amount keeps getting bigger and bigger each time. You can see how it just started off as 5, okay, and this time it was 10 more than originally, okay, then it became 15 more than it was originally. So this number gets bigger and bigger, so compound interest can increase fast. So let's think about that. If we compare simple interest to compound interest, which is better? And is it always better? Well, in this case, compound interest is better because we earn more money. But is there ever a case when it would not be better? Well, how about when you're borrowing money? So if I'm borrowing money, let's say on a credit card, would I rather them charge me a simple interest, okay, which is going to be less, or would I rather them charge a compound interest, which is going to be more? Right? So it really depends on who's getting the interest, right? All right, so compound interest is better if you're getting the interest. But simple is better is better if you're paying the interest. So again, compound interest is going to go up faster, which is great if you're the one getting paid. Not so great if you're the one doing the paying. Okay? All right, so here's the formula for compound interest. Rather than have to go through this big, long table each time you want to find compound interest, there is a formula that gets you kind of to the end a little faster. All right, so compound interest formula uses the same letters. P is still the principal rate, is still the rate in as a percent, but you change it to a decimal. And then T is going to be time, but it's going to be in years. Okay, so A is just going to stand for the amount of the balance, right? So it's calculating this number right here, not the interest, but the whole amount. All right, so that's a little different than the interest formula, which just finds the interest. Maria deposits $450 into a savings account. If the interest rate is 2% compounded annually, so that word compounded is what's telling me that I'm going to use this formula here. What is her balance after 3 years? How much interest was she paid? If it doesn't say compounded, then we would just use the simple interest formula. But since it does, we're going to use this formula right here. All right, so P, I need to find the principal. That's the amount she deposits, so $450. The rate is 2%. I'm going to change that to a decimal, so 0.02. And the time is 3 years. That's good because it's in years 3. All right, so now if I use this formula, A equals the principal, which is 450 times 1 plus the rate, which is 0.02 to the exponent of 3. All right, so I'm going to start with my parentheses. If I add 1 plus 0.02, now if you can't just do that in your head and you need to line it up, then you're going to have to add 2 zeros to the 1 so that you can add the decimal 0.02. Right, but this ends up being 1.02. So now I have 450, in parentheses I still have 1.02, and then I have this little 3. Now if you remember from last year, because I don't think we've talked about it yet, this is an exponent, and the exponent tells you how many times to multiply the base. So what I need to do is I need to multiply 450 that first, because I do exponents first, I need to multiply 1.02 times 1.02 times 1.02, because that exponent tells me how many times to multiply that number. 1, 2, 3, because there's a 3 here. Now, This could take a really long time. So for today, we're going to do the easy way. I'm going to let you use a calculator for compound interest only, right, to multiply, because these you can get really bogged down in this. So I'm going to go ahead and start with the first two, 1.02 times 1.02, right? If I punch this into my calculator, 1.02 times 1.02, then I get 1.0404, right? Then I still need to multiply times this 1.02. So I'm going to multiply times 1.02. And I get this long number, 1.061208. Okay, which I still need to multiply. So I've done these three times 450. So now I need to multiply times 450. This is why you're getting to use a calculator. But only this time. Only on this stop. Okay, so I get this number here, 477.5436. All right, so this is not an amount of money, okay, but what I'm doing is talking about money, so I want to go ahead and round it so that's in money. $477 and what, 54 cents or 55 cents? Well, I look at this number here to round to the nearest hundredth. Since this is not 5 or bigger, then this just becomes $477. Oops, I'm gonna write it over here. $477.54. All right, so what is that? That's not the interest, that's the whole amount. So that's the balance, it's the $450 plus the interest. Okay, so that right here is the balance. That answers the first question. Okay, I also want to know how much interest was he paid. All right, so I want to compare that to what it started as. So it started off as $450. So how much of this is interest? In order to find that, I need to subtract. So I'm going to take the $477.54. Now I'm going to subtract $450. I'm going to line up my decimal, so I'm going to add 2 zeros. Bring down my decimal. So $27.54, that's the interest that was paid. Okay, so a little different than the interest formula. Simple interest formula, you find the interest rate first, or the interest, and then you can add it to the principal if you want to. With compound interest, it tells you the total first, and then if you want to find just the interest, you have to subtract the principal. Okay, so let's look at one more. Justin charges $750 on his credit card to buy a new television, and if his card charges an interest rate of 1.5% compounded annually, that's telling us to use the compound interest formula, what will his new balance be after 2 years? All right, so I need to find the same 3 letters. Principal is what he borrows, so $750. Rate is the percent. Change it to a decimal. Here I just have to still move the decimal, 0.015. And then time is 2 years, so that's good because it's in years, so 2. So if this is my formula, I'm going to plug in P is 750, 1 plus R is 0.015, and T is 2. All right, so if I add 1 plus 0.015, hopefully we can skip to just 0.1015. With an exponent of 2, that exponent tells me how many times to multiply this number. So what I need to do is 750 times 1.015 times 1.015. Right? Because I'm so nice, I'm going to let you use the calculator for this step only, and you get to multiply 1.015 times 1.015, and that gives me this number. Okay, so now I have 700, I'll do it over here. 1.015 times 1.015, and then I got 1.030225. Okay, but I still need to multiply, that's just these first 2 numbers, so I still need to multiply times 750. And multiply times 750. I get this long number, 772.66875. Okay. Now, this is money. This is not money, or it's not in the form of money. I only want cents, right? So I need to decide if this is going to round or not. So since the 8 is 5 or bigger, it's bigger than 5, then this rounds up to a 7. So this actually becomes A is going to equal 770. Hang on, let me try that again. A is going to equal $772.67. Okay, and remember, A is the whole amount, right? So if I had charged $750, okay, that's how much originally the television cost me. The end of the 2 years, though, now it cost me $772.67. Okay, so this is one of those cases where interest, compounded interest, not so good for us because now I owe more than what I did originally. Okay, and if I keep waiting, if I keep postponing paying for this, this is going to get bigger and bigger. All right, so that's the amount that I owe now. And that's all they want is the balance. So so I can stop here because I've answered the question. But if they had a question like this last one, if they asked specifically, oh, well, what's the interest? Then I would take this amount and just subtract the $750 to find the interest only. Okay, so compound interest uses the formula right here. A equals P times 1 plus R to the power of T. And again, compound and simple interest, okay, depends on which one, and if you're being paid the interest or if you're paying the interest as to which one is better or not. All right, if you have any questions, let me know. I'll see you in class.